Hi everyone, my name is Sean, and I'm here today with my colleague Greg from Ripple, and we're excited to show how real-world assets can be issued using a new upcoming proposal called Multi-Purpose Token that will be introduced on the protocol layer of the XRP Ledger. So this is the agenda for today, and we're going to look at what's a multi-purpose token, also known as MPT, and why we need it on the ledger. And then we would explore some of the high-level implementation details, and we'll go over a demo, going over a very basic example. And after that, we will talk about how MPT will be integrated with features like DEX and AMM. So what's a multi-purpose token? It is a new token standard that we're working on the protocol layer that offers a wide range of functionalities to help to combine fungible and non-fungible functionalities. It's something that was born out of the needs related to the tokenization of real-world asset. So let us explore some of its functionalities. First, it has the ability to store metadata on-chain. And second, it also allows listing or authorization, which is the ability to allow issuers to authorize certain accounts before they're allowed to own particular tokens. It has a fixed supply of tokens, so it's basically a field to store the max supply of tokens that can be issued out. It also allows lock and clawback, so the issuers are able to lock and clawback their tokens. Lock is basically another term for freeze. And then it also enables bulk or fractional transfers, which is for some real-world assets, it's not really possible with NFTs because you can't really fractionalize NFTs. And at last, it also comes with space-saving benefits on the ledger. So why do we need MPTs? A question that many of you would ask is why we need another token standard. And the short answer here is to allow the tokenization of real-world asset. So how exactly is MPT different from IOUs today? On a technical level, MPTs provide a fundamentally different way of representing fungible tokens on the ledger. While IOUs are represented by trust line and have a bilateral debt relationship, MPT uses a much simpler unilateral relationship captured by a MP token object, which corresponds to space savings as well. The representation of a fungible token as a token object instead of a trust line makes it simpler to enable tokenization of many use cases. And the next question you guys may ask is MPT intended to replace IOU? And the answer is no. While there might be overlap where both MPTs and IOUs are both suitable, there is the need for both over the long term. For MPTs, it can support tokenization of fixed income securities like bonds, or it can be used for unlisted equity, such as private equity funds. These use cases will find on-chain metadata to be very useful. And on the other hand, IOUs will remain to be more suitable for use cases such as credit lines for lending and borrowing. So now let's dig into how MPT is implemented from a high level. So we introduced two new object types. The first one is called MP token issuance, which is the object created by the issuer of the token, and it's a single object that can store the information of the issued token. The second object is MP token, that's created by a holder account and stores the balance of that particular holder. And the relationship between MP token issuance and MP token is a one-to-many relationship. So now we're going to dive deeper and explore what MP token issuance object can store. The MP token issuance is the central object that stores the data about the issued token. So it contains the following field. Issuer is the issuer of the token. Asset scale is the number of decimal places that the token can be fractionalized for. Maximum amount is the total amount of tokens issued out. Outstanding amount is the total amount of tokens that's currently held by the holders. And transfer fee is the percentage that will be deducted when a transfer of fund occurs between holders. And at last, MP token metadata is a field where the issuer could lay out all the relevant details of the token. And then on the right, here showcases some of the flags that will be supported, but I won't go into each of them in detail, but it allows the issuer to configure for things like authorization, locking, and a clawback. Next up, let's look at what the MP token object looks like. So the first field is an account that owns the MPT. And we can see that the second field, MP token issuance ID, points to a specific MP token issuance object it's referring to. And thirdly, the MPT amount refers to how much the token holder account currently owns. And then on the other side, here are the object flags that indicates whether the holder has been locked or authorized by the issuer. Cool. Now let's take a look what changed to the transactions. There will be some new transactions and some existing ones will be changed. So the first two here are pretty self-explanatory. The MP token issuance create transaction creates an MP token issuance object, which is always the first step to issuing your token. The MP token issuance destroy will permanently destroy the issuance object, meaning that the issuer can no longer issue this token. The MP token authorized serves two purposes. So the first purpose is to allow non-issuer account to submit the transaction to start holding to the token, which is quite similar to how trust set works for IOUs today. And the second purpose is if the token has enabled authorization, then the issuer needs to use this transaction as well to authorize a holder account. The MP token issuance set is a transaction that can globally lock or individually lock funds. So in addition to these new transactions, we have the existing ones are unchanged. The payment transaction is updated to support MPT transfer between two accounts. And also clawback is updated as well. So now let's take a look at an example of issuing a US Treasury bill. On the side, it shows an example of what the metadata could look like. And as you see, it stores a lot of the relevant information, such as the name of the bill, total supply, face value, etc. And we will be using this example throughout the presentation. So now let's find out how we should configure the token using this metadata. So first, the max supply is set to 1 million tokens, each of which will have a face value of $1,000. Second, authorization is enabled such that the issuer must approve an account first before it's eligible to own the Treasury bill token. And third, both lock and clawback are enabled to ensure regulatory compliance and fraud prevention. And at last, transfer fee is set to 0, meaning that the holder of the bill token are allowed to transfer between each other without the need to pay for fees. So now let's use the Explorer to see a basic MPT flow using the Treasury bill example. For the setup, we're going to use one issuer account and one holder account. So the first step here is that the issuer submits a MP token issuance create transaction for this Treasury bill, specifying the configurations, which in turn creates a new MP token issuance object. So this page displays all the configurations of the token we just created. We can see that the asset scale is 2, meaning that the token can be fractionalized up to 2 decimal places. The max supply of token is set to to 1 million, but because we have an asset scale of 2, we have to multiply 1 million by 10 to the power of 2, and that's why the maximum amount actually says 100 million in our case. The transfer fee is set to 0% to allow the holders to exchange tokens without the need to pay fees. And in the metadata field, the object stores the treasury bill metadata, and as you see, it's very beneficial to actually see the information on chain. And then we can check the flags that we enabled for this token. So it enabled both locking and clawback for regulation purposes. It also enabled authorization, so someone who wants to own the token must be authorized by the issuer first. And CAN transfer is enabled, so the holders are allowed to transfer tokens among each other. The second transaction is MP token authorized. So this transaction is submitted by the holder to declare that they want to start holding the treasury bill token. And as you see, the holder specifies the ID of the token that was auto-generated from the previous transaction. And as a result, when we check the metadata it created, a new MP token object is created under this holder account, and the initial balance has a default value of 0. Moving on to the next transaction, it's basically another MP token authorized, but this time it's actually submitted by the issuer. And the reason why is because this treasury token has enabled authorization, so the holder cannot own any of the token until the issuer has approved their account. And we see here in the payload, the issuer specified the MPT as well as the holder account that they want to authorize. So now, after the holder has been authorized, the issuer can now transfer 10 tokens to the holder through a payment transaction. And the reason why here it actually says 1,000 is because of the asset scale of 2. So the actual token amount is equal to 1,000 divided by 10 to the power of 2. And similarly, if this holder wants to transfer the MPT to someone else, then they could use this payment transaction as well. So now when we look at the metadata for this payment transaction, we can see that in the holder MP token object, the MPT amount changed, and it says 3E8 in hex, which is equivalent to 1,000 in decimal. So what if the issuer now discovered that the holder to whom they've just authorized and sent some tokens to is actually a bad actor? In this case, the issuer could lock through a MP token issuance set transaction by setting this MPT lock flag. And this will prevent the holder from transferring or receiving tokens. And at last, the issuer may choose to claw back 1 token. So now, if we go to the holder's account view and check their asset, we can see that they have 9 tokens left, since previously they had 10 tokens, and then the issuer clawed back 1 token. And this basically sums up the basic flow of issuing the treasury bill on XRP Ledger. And now I'll pass it to Greg to talk about integration with AMM and DEX.
Thank you, Sean. Hello, everyone. I am Gregory, and I'm going to give an introduction of the future integration MPT into DEX. So let's start with the current state of the DEX. What is it today? It is efficient trading. DEX enables anyone on the ledger directly and efficiently buy, sell, or trade any assets without an intermediary, like a bank. It is a powerful matching engine. So in the simplest terms, DEX is a central limit order book. Sellers set asset prices, buyers issue purchase orders, and the DEX matches the two to finalize transaction. It includes pathfinding, and pathfinding is the ability to hop between currency pairs with the most liquidity, essentially finding a path from the seller to the buyer. It's auto-bridging, and auto-bridging uses XRP as an intermediary to connect currencies or tokens at the lowest cost. And the way traders interact with DEX is via AMM create deposit withdraw transactions, which create AMM and interact with AMM. Offer create, which is an instruction to conduct a trade. And when transaction is processed, it consumes matching or crossing offers, so AMM. It's cross-currency payment. Cross-currency payment consumes offers, so AMM, to convert from one currency to another. And it's check, create, and check cash, which creates a deferred payment. And this payment can be cashed at a later time by the destination. And what MPT is going to support? Well, it's going to support all of the above. It will support pathfinding and auto-bridging, all AMM transactions, offer create, cross-token payments, check create, and check cash. And it will support any combination of MPT token with another token type, like MPT IOU, MPT XRP, and MPT and MPT. So what does it mean from the trader's perspective? Let's consider offer create example, and let's look at IOU and MPT. So for IOU, trust set has to be submitted to establish a trust line between the issuer and account. Account has to be funded with IOU. And finally, offer create has to be submitted. For MPT, MP token issuance create has to be submitted to create the token. MP token authorize has to be submitted to enable account to hold MP token. Account has to be funded with MPT. And finally, offer create has to be submitted. And the only difference between offer create for IOU and offer create for MPT is how the token is identified in the transaction. For IOU, token is identified by currency and issuer pair. And for MPT, the token is identified by MPT issuance ID. That's all. That's the only difference. So let's run a demo. Let's consider this example. For instance, Carol. So Carol wants to send M bonds, municipal bonds, to Bob as a gift. Let's say it's 12th anniversary of Bob trading on the XRPL Dex, which is actually in June. And Carol wants to pay for the M bonds with treasury bills. And both M bonds and T bills are MPT tokens. And let's assume that central limit order book has T bills and M bonds. And also there is AMM liquidity for the same token pair. I have a Ripple D implementation with MPT prototype, support of the DEX. And I have local network running on my laptop. And I also have a console app to run a JSON script that executes the demo that I just described. So let's just run this script. This app is like a shell-like interface, and it has pretty straightforward commands, as you can see. Self-explanatory. It has history, and I can just run history into 654 to run the script. And so what happens is it first creates accounts. And it basically tells the app, call wallet create, and fund accounts is 1,000 XRPs. And accounts are identified by these friendly names. This is just internal names, and they map to the actual address, but I can use these names in the commands. And then MPTs are created. MPTs are authorized. Account is funded with MPTs. And then next, offer created. So let's look at the offer create in more detail. I actually printed JSON payload for this command. So this is offer create transaction. And as we can see, MP tokens are identified by MPT issuance ID. And this transaction is to sell 100 M bonds and buy 100 T-bills. Next transaction is AMM create. So some account and issuer creates AMM for 1,000 M bonds and 1,000 T-bills. So here is a payload, JSON payload for MM create transaction. And we can see again that T-bill and M bond are identified by MPT issuance ID. And lastly, Carol submits payment to Bob. So she wants to send 110 M bonds to Bob and pay for the M bonds with 110 T-bills. And this is JSON payload for the payment transaction. And again, as we can see, MPTs are identified by MPT issuance ID. And another important point is that you can actually use MPTs to specify path. Here the path is specified with MPT. And again, we just use MPT issuance ID instead of currency and issuer. So it looks like this transaction is successful. And I have a few APIs here to look at the ledger state, but let's just skip to the metadata. So this command submits a TX API to the network, to the local network. And TX hash is just an external variable that keeps payment transaction hash. And these parameters in the end just tell the application to only output objects with a ledger entry type offer and MP token, and only output MPT amount, account, and MP token issuance ID. So this makes it easier to look at the result. So this is kind of reduce the metadata. And so when we look at the metadata for the payment transaction, now that we have AMM, one answer that we want to one question that we want to answer is what kind of liquidity the payment consumes, because it could be offer from the limit order book, it could be AMM, or it could be both. So what we want to look at the offer object, and we want to look at AMM. And offer object is offer, has a ledger entry type offer. It's easy to identify in the metadata. Here is the offer object. And as we can see, initially the offer has 100 M bonds to sell and 100 T-bills to buy. And the offer is deleted from the order book. So next is AMM object. And so the way you have to identify AMM in the metadata is basically to match AMM account, which might not be easy in some cases. I mean, you can still do it, but you have to look at quite a few objects. So what we're going to do, we're going to add another flag to MP token object. And this flag would identify MP token object as owned by AMM. And MP token object is actually created by AMM on AMM create transaction. So anyway, you should be able to look at this flag to identify AMM. But in this case, we have AMM with initial balance of 1,000 M bonds and 1,000 T-bills, and the final balance is 990 M bonds and 1,010 T-bills. So basically, 10 T-bills got swapped in, and 10 M bonds got swapped out. So to recap, we had an offer of 100 T-bills to 100 M bonds, and we had the AMM. Offer is fully consumed. 100 M bonds is transferred to Bob, and in addition, 10 M bonds from AMM is also transferred to Bob. So if you look at Bob's account, we can see that initial balance for M bonds was 0, and final balance for M bonds is 110. So Bob got his full payment of 110 M bonds. And if you look at the Carol's accounts, we can see that initial balance is 110 T-bills, and final balance is 0 T-bills. So to recap, if you want to trade MPTs on the DEX, if you want to buy MPTs with offer create, you don't need to call MPT authorize. It's going to be done for you. It's consistent with how it works for IOU. Trust line is going to be automatically created for you. If you want to use different transactions, you have to authorize your account to hold MPTs. You have to fund your account, and then you have to call one of transactions. And all you have to do is basically replace currency and issuer for each MPT token with MPT issuance ID. So this is really straightforward for developers and for the traders. And this concludes my presentation. Thank you.